Hey everybody, it's Tom Cherams with the FujiNet project, and I wanted to show what I'm currently doing right now in the Apple II target, which is trying to take the network functionality that's present in the FujiNet and expose it out to the underlying basic system that's on ProDOS using the external command function. If you want to follow along with what I'm doing, the work that I'm doing is in the FujiNet-and handler repository. You can grab it on GitHub alongside all of the rest of the FujiNet code at FujiNet Wi-Fi /FujiNet-nhandler. And I'll be working in the Apple II. And right now, in order to work through the various issues that I'm doing, we have the indev, which will have the finished handler when it's ready. But we also had a series of prototypes for each command so that I can work out the calling conventions and try to debug as much as I can before we start to take and put all of this together. We open it up. The source to this, we'll see that we have, it's all written in assembler, 6502 assembler. We have a handful of useful variables for various vectors and buffer spaces inside of the Apple II that we're going to be using. And the very first thing that we're doing once we actually enter this entry point is we immediately take the existing external command, save it, and then insert our handler here in place. We do this so that if we take and process the command here to match and it doesn't match, then we can go down here to not ours and jump through the vector for the next command that we saved so that we don't overwrite any other additional code that might be there. At least for right now, I'm assembling to 0300. This is just a nice empty space. If you're not familiar with Apple II programming, it's just a nice little empty space. It's about 200 bytes or so that you can use for your own routines that nothing will typically touch. And just building the commands here, and then when I'm ready, I'll bring them all together, make sure that they work together in a non-relocatable format, and write a page-level relocator to move them into place using the BASIC.SYSTEM buffer allocation routine. So the command that we're implementing here is inopen, which opens a network socket. That's its whole purpose. It either opens up a network socket or it returns an error if it can't do so. Assuming that we have parsed and we go through our command, it's really pretty simple. I'm actually taking and repurposing the getLine buffer for my own use here, just for this open command, because there's no reason for me to go grab a buffer just so I can pass a command. So I use page 2. It's 256 bytes normally used for the line input routines in Apple II. We go ahead and check, see if there's a file name, and if there isn't, we do a syntax error and return. Otherwise, we use the built-in functionality that's present using the F-bits and P-bits bit fields that are in the basic system to indicate which are valid parameters. And for inopen, we have two of them, one for file name and one for type, which is I'm reusing as mode. So that you can say for like HTTP, you can do get, put, post, that sort of thing by setting the type. So we go ahead, we grab the path, put the buffer in here, and we copy it over from vpath, which is the area that Basic System did, over into our getLine space here. And the reason I'm doing that is because I'm constructing the exact sequence of bytes that I'm sending over the character device, open the socket. I'm building everything in place. Copy everything over, and then When that is all said and done, and everyth's in place, we then immediately, since this is a prototype, I'm assuming slot 5, we call the smart port dispatcher to issue a control command, and the parameter list for my control command is essentially 3 parameters, which indicate the device and the location of the payload that we're going to send, and the open command. So a little bit about the payload. The first 2 bytes are the length of the entire payload. The next 2 bytes are the mode and translation modes, and the rest is the URL. So once we take and compile all this together, and you can compile it, and MakeGist will actually pull all this together for me. It takes and builds it if it needs to, creates the inopen disk image, and then copies it to my TNFS server so that I can take and use it. So with that, we can actually now go over here. I already have it mounted, so I just reboot to go into it. We can see the catalog here of my inopen test. We go ahead and run it, and which it installs the vector. Once that's done, we can now use it. Now, inopen is intended to open a network socket, and it's not really meant to be used outside of a program. So if we try to use it at this point, you'll see that it's not a direct command. No problem. If we go ahead and make a quick program, we can use it like a DOS call with the n colon functionality, with the n colon URL that you use on all the other FujiNets, which specifies the protocol, the host name, port, everything that a protocol needs for to connect. In this case, we'll connect over to TMA2 port 6502. There we go. Now I'll go ahead as part of this process here, and we'll start a listening socket over here on TMA2 at port 6502. Now I'll go ahead as part of the process here, and we will just gently take a little monitor window that we have right here so that you can see a bit of what's going on. I apologize, I'm scooting this over so that you can see. We run. You see it form the command, bring it over, and the FujiNet does the open and sends over the success. And we see right over here that we've connected. The first part of this is done. And I'm doing this for each command: in open, in close, in read, in write, etc. So that you'll be able to take and use all of the network socket functionality from within your AppleSoft BASIC program. So until next time, guys, have fun.